think they know that we're recording?
Hello! Hi audience!
We're recording. Gabe, again, we're recording. Gabe, sit flat, turn around. Gabe, again. Well, hello, good day. That was kind of a lame intro because you people didn't stop talking. We are doing the first page of PO22 because it's a little more tricky than the second page. Okay, on the second page we went from Slope-Intercept, from standard form to Slope-Intercept form. Today we're going the other way. We're going from Slope-Intercept form to standard form. And what makes this a little bit tricky is, if you remember yesterday when we talked about standard form and the fact that it was ax plus by equals c, what did we say needed to be true about a, b, and c? It was a brief mention, maybe you didn't pick up on it, but what needs to be true when in standard form about a, b, and c? That, if you look at the second page, every equation that I gave you in standard form that you needed to convert, this was true for. What must be true about a, b, and c when dealing with standard form? Anyone have a thought? Yes?
They must always be there?
They have to always be there, okay.
Right, get it?
Here's the kicker with standard form. A, B, and C must be, starts with an I, and then integers. Integers must be integers, meaning they cannot be decimals, they cannot be fractions. Okay? Now why that makes this a little more tricky is because slope-intercept form often has fractions, because the slope is usually written in fraction form. If it's not something like 4, right, it's in a fraction. So not only do we have to convert from y equals mx plus b to get x and y on the same side, do all that stuff, we also have to undo or get rid of any fractions that might exist. Okay? So it's a little bit extra step. But to convert from slope-intercept form to standard form, you are first going to move the mx term, because in slope-intercept form it's mx, in standard form it was ax, but it's kind of the same thing there. Move the mx term to the other side using opposite operation. So that part does not change. You are still starting with that x term and moving it over. Okay? The second step, because once you move this x term over, x and y are on the same side, you're in standard form. But if you have any fractions, you have to undo the fraction. Who knows how to undo a fraction?
Turn it into a decimal. Multiplication.
Well, integers aren't fractions or decimals, so it can't be either. In multiplication, what do you have to multiply by? Like this 3/2 here, how do we turn that into an integer? Or a non-fraction? What? Yes. Okay? Multiply all terms by the denominator or least common denominator, if you have more than one fraction, which we'll talk about, by the denominator or least common denominator of the fraction or fractions, if you have multiple. Multiply all terms by the denominator or least common denominator of the fraction or fraction. Okay? So, let's do the first one. Y equals 4x plus 7. Step 1. Move the mx term to the other side using opposite operation. So since this is positive over here, how am I going to move it to the other side? What do? Subtract it. Okay? Opposite operation. Minus 4x minus 4x. And I can't combine the x and the y term, right? Because they're different variables. They're separate in standard form anyway. The x term does come first. So this would be negative 4x plus y, because y is positive. So plus y equals, what's left on the other side? 7. And we're done.
That's it?
Yes. Okay. We don't have any fractions. There's no denominator to multiply by. So we are finished. This is in standard form, negative 4x plus y equals 7. Okay? Not too bad. The next one, however, does have a fraction, so we will have to do step 2. But we start by, again, moving it over to the other side using opposite operations. So we are going to be subtracting 3/2 x from each side of the equation. On the left side, that gives us negative 3/2 x plus y equals negative 5, because those x terms cancel out there. Questions on that so far?
No.
Okay? So we have that fraction there. We're not done because a cannot be a fraction. It must be an integer. Step 2 says multiply all terms by the denominator or least common denominator of the fraction or fraction. We only have one, so we're only looking at the denominator of the fraction. And Emerson says we have to multiply by that 2. Why does multiplying by 2 undo the fraction? Henry?
Because the numerator is higher than the denominator, so that means
Nothing to do with that. Caleb?
the fraction is divided by
Right, we're undoing dividing by 2, right? It's still opposite operations. If we're dividing negative 3 by 2 to undo that, we would multiply by 2. Mathematically, if you take negative 3/2 and multiply by 2, which is 2 over 1, you get negative 6 over 2, which is equal to what?
negative 3.
Negative 3. Essentially, these 2's cancel out because we're undoing dividing by 2. So when we multiply by 2, those cancel out. We're left with negative 3, but we also have to multiply the y by 2 and the negative 5 by 2 to keep things balanced. So in the end, we just have negative 3 as our a term, our coefficient to x, because those 2's have been canceled out. That's what we wanted. That's why we multiplied by 2 and not by 7 or 5 or anything like that. Y times 2 is 2y. Right? We have y, we double it, now we have 2 of them. And negative 5 times 2 equals negative 10. And there would be our equation in standard form.
Awesome.
Okay? Awesome, indeed. Yes?
When it's 3/2 like that, since we know the decimal for that is 1.5, can we just use that
Write 1.5x?
instead of negative 3 and 2y?
Well, an integer is a non-fraction, non-decimal. So no, you could not write the 1.5. It would have to be an integer value. Okay? I'm going to scroll up a little bit, just because the next one, I don't want to squish my work. I want you to be able to see what's going on here. So if you need the notes, anyone need notes quick, we can grab them, or can I go up?
You can go.
Okay. All right, the third one, double fraction. Yikes. All right, y equals negative 4/5 x minus 3/10. The first step doesn't change. Opposite operations, move that x term over. What are we going to need to do for that? Add 4/5 x to both sides here. Plus 4/5 x, plus 4/5 x. See, that's not very neat. Plus 4/5 x plus 4/5 x. There we go. So that gives us 4/5 x, now positive, plus y equals negative 3/10. Okay? Now, if we only had one fraction, right, I'd multiply by 5 here and we'd be good. Correct? Because it would cancel out, we'd just be left with 4. But if I multiply this one by 5, they're not going to cancel out. Negative 3/10 times 5 over 1 equals negative 15/10. That's not an integer value. Okay? So that's why we have that multiplied by the denominator or the least common denominator. What is the least common denominator of 5 and 10?
2.
You're thinking factors.
10.
2's not a factor of 5 anyway.
20.
10 is, right? 10 is the least common denominator between 5 and 10. So that's the number we're going to multiply by. Multiply this by 10, multiply this by 10, and multiply this by 10. Okay? This time they don't directly cancel out, but it still ends up being an integer. because 10 is a multiple of 5. 4 times 10 is 40. Divide by 5, this becomes 8x. Everyone see how I got that 8?
Yes.
Okay? If you think about it mathematically, 4/5 times 10 is literally this. 40 over 5, which equals 8. It's not going to be a negative 8 because I added 4/5 x to both sides to move it over there. Right? The sign changed when I moved it from the right to the left. And then what's my y term become? 10y. And my fraction on the other side? Negative 3, because these do end up just straight up canceling out. Right? Because you're dividing by 10, multiplying by 10. If you multiply it, you get negative 30 over 10, which equals negative 3. Okay? And that would be our final answer there. Right? So, as you look at the rest of the page here, you are very happy when you don't see any fractions, because there's only one step to get it in standard form is move the x term over and you're done. A couple of them have 2 fractions, or a couple have just one fraction, and then the bottom 2 each have 2 fractions. So we got about 10 minutes left. What would you like to go over? I have a guess. We're not going over both of them. We'll go over one of them. Which one?
The second one.
Which one would you like?
Second one.
The last one?
Last one.
Like
Yeah, the second.
the 7/6 one or the negative 3/8 one?
Last.
Say that. I can't.
Last
This.
one.
Okay. So y equals negative 3/8 x plus 9/5. Our first step, always the same. Move that x term over. It's negative, so we'll be adding it to both sides. That's going to give us positive 3/8 x plus y equals 9/5. Because that 3/8 x term cancels out. So now we're looking at our denominators. Multiplying by 8, we'll get rid of the first fraction, but not the second. Multiplying by 5, we'll get rid of the second fraction, but not the first. So again, we're looking for that least common denominator. And what is the LCD, the least common denominator between 8 and 5?
40.
40. So that's what we're going to be multiplying for. Okay? So if you think about this, and this is why I write the times 40 kind of up here, because it makes it a little bit easier to do in your head, right? 3 times 40 is what?
120.
120. 120 divided by 8 is what? 15. So this becomes a 15x, right? And then our y term, multiply by 40, that becomes 40y. And then 9/5 times 40.
360.
9 times 40 is 360. 360 divided by 5?
360. 72.
72.
What? I thought we were doing 40 times 9.
Is it carrot?
9 times 40,
Yeah.
and then divide that by 5.
Oh, to divide on the
Yeah, don't forget about the original fraction.
I think it's
divided by 5.
I think it's red.
Okay. Lucas, Christian, 5 please. So that's the gist of it. Okay. People struggle more with this when going from slope-intercept to standard than they do going from standard to slope-intercept because of that fraction, right? But how to convert that fraction to an integer, multiplying by the denominator or the least common denominator of the fractions. Okay? Anybody super duper lost?
Nope.
Okay if you are. Kind of?
Kind of.
Okay. Let's do the y equals negative 2/7 x plus 10 here.
I've already done it.
Lakely, what would your first step be in this y equals negative 2/7 x plus 10? Matthew?
You have to add
Yeah.
negative 2/7.
So not add negative 2/7, but just add 2/7.
Yeah.
Okay? Adding negative 2/7 would be the same thing as subtracting 2/7, which wouldn't cancel this out here. We are going to add 2/7 x to both sides because it's negative. Move it over. Opposite of negative is a positive. Right? So now we have 2/7 x plus y equals 10. And we only have one fraction to worry about here. Okay, so you can go back to the top. You say, okay, what's my strat here? What's my next step? We're multiplying by the denominator of the fraction, which means we're multiplying by 7. Okay? And again, you know, really these 7s end up canceling out. But the reason why, mathematically, is because 2 times 7 is 14. 14 divided by 7 equals 2. So this becomes 2x. Then we also multiply the y by 7, and the 10 by 7, and so that becomes 7y and 70. Okay? When you have more than one fraction, that's when it gets a little bit tricky. That's where we have this LCD over here, and you can't just straight up cancel them out like ends up happening here. You have to actually think about it. I'm multiplying by 40 because that's the LCD of my 8 and my 5. So 3 times 40 is 120 divided by the 8. 9 times 40 is 360 divided by the 5. Okay? And those will give you your values there. Roy.
If you could only karaoke one song against Jesus, the one Christmas song against Jesus, what song would you karaoke?
Oh.
Silent night.
Nice.
Oh. Sing it.
It's a good karaoke.
For camera, for the video.
I'm doing
Alright. I would like you to do these 6 or the 4 that we have left, or however many, 3 of them. We have 3 of them left? 4 left? 4 left. 4 homework for tomorrow. Don't worry about that bottom part or back side. I've not decided if we're going to go through it yet or not. Just this first page for homework. That's how you math.